On to some path-breaking stuff that's happening right here in India. Now, after a few attempts, the Indian space startup Agnikul Cosmos last month was able to find a breakthrough by successfully carrying out the suborbital test flight for its home-built 3D printed semi-cryogenic rocket. That's right, 3D printed, meaning having a rocket ready in just 3 days. Yes, you heard that right. And it all happened in India.
Now, obviously, this signals the ability to rapidly assemble rockets at a very, very reduced time. It's obviously also cost boosting the country's spacefaring capabilities. This opens up a whole new realm of possibility. Now, the maiden flight was also the country's second private rocket launch, the first to demonstrate the use of semi-cryogenic engines. And joining us, we're so excited to have the man behind all of this, or one of the men behind all of this. This is Satyanarayanan R Chakravarthy of Agnikul Cosmos. He's a professor of aerospace engineering at IIT-Madras. Professor, thank you for joining us this morning. Thank you for taking out the time. Tell us, Professor, just to really, for our audiences, break it down, just tell us, what are the key milestones that this achievement has unlocked?
Yeah, I think the world record that we are talking about here is about the single-piece 3D printed engine. I think 3D printing technology is now developing around the world, particularly in rocketry. There are a few other companies that are trying out parts of rockets that actually could be 3D printed in order to integrate multiple subcomponents and so on. But what we have done at Agnikul Cosmos at IIT-Madras is to actually integrate about 1,000 pieces together and saved about some 3,000 joints all in a single piece, starting from the inlets of the kerosene.
Oh, nice. Nice. That's a lot of science behind all of this, Professor. We don't claim to be knowing a lot of it, but just in terms of understanding how path-breaking this has been, can you give us a sort of a time comparison on how much time was actually saved, like a 3D printed rocket versus making one the conventional way?
Yes, what we have purported to do right from the beginning at Agnikul is to, our tagline is actually launch anywhere, anytime, affordably. And each of these aspects is quantified. The anytime part is actually what is highlighted by the 3D printing capability, where we are in a position to actually print an entire engine in about 3 days. And a full rocket that goes to space, unlike the one that happened yesterday, which is a suborbital rocket, in our configuration involves about 8 engines, about anywhere between 4 to 7 engines for the first stage and 1 engine in the second stage. So that would actually be somewhere between 5 to 8 engines total. And we have the ability to be able to print 2 engines simultaneously in one printer bed in 3 days. And if we have let's say 2 such printers in the near future, we will have the capability to print about 4 engines in 3 days and another 4 engines in another 3 days. So within about a week we will have all the engines done, and we can spend the next week in assembling all of them together potentially, which means that we can get a rocket up and flying from scratch within about a 2-week period is the ultimate goal.
Professor, can you set this for us in the context of the larger Indian space movement, India's space dreams for itself? What does it mean in that context?
So the 3D printing I mentioned actually takes 3 days. The 3D printer actually does not really bother about the complexity of the machinery that is getting printed, provided we are able to actually do this within the tolerances it can do, and that's the design process that we have to build into it. But a equivalent conventional engine will have at least about 1,000 different parts that will have to actually be put together. Each of these parts is very minute, and they require precision micro machining in the first place with very high tolerances, and then they also actually have to be very precisely assembled, and they will have to go through something like about 3,000 welds.
Right. Professor, we spoke about the time being significantly less. What about the cost then? We understand India is making waves when it comes to our aeronautical engineering, what we're doing with our space mission as well. How do we weigh there for 3D printed rocket versus the traditional way?
Yes, this is actually opening a new era of rapidly developing engines. So I think the point that I was just coming to is that the conventional way of doing this actually takes anywhere between 1 to 3 months when compared to 3 days. And I think recently ISRO has also actually started embarking on trying to convert some of their existing smaller engines that are used in upper stages of their launch vehicles into 3D printed ones. So in that sense, we are actually a bit proud that we have pioneered the entire process in India.
That's lovely, Professor. Thank you so much for joining us, and congratulations again on everything that you and your team is doing. Look forward to what next you guys bring to the table.